Hello, this is for CIT 371, Linux System Administration. In this lecture, I'm going to be covering file system and RAID management. So this lecture is going to be used to provide an overview on Linux file systems, and then I'm going to discuss an overview of RAID and the types of it available. I will say there's a lot of different types. I probably won't list them all by name, but you can read them in the lecture, so I don't take up too much of your time. And then I'm going to end with a brief overview of the lab for this module. So I have an article from open source here. It's linked here in case you want to read it from the PowerPoint. It defines the term file system in three ways. So file system can refer to the Linux directory structure, starting from the root directory, or just slash, all the way to the very last subdirectories in it. So it can just refer to the entire file system, all the files and directories in it. A file system can also refer to a data storage format type, each of which have different ways to define how data is accessed and stored. So it could be a format type of file or storage. Then file system can refer to a mountable partition or logical volume, like you can think like a USB drive or external hard drive. So throughout this course, you've gained extensive experience navigating the Linux file system in the context of the first definition. So I want to note that the reason I gave out these definitions is because we're actually going to be covering the two other ones, the data storage format type and then the mountable partition. So file system types. So Linux supports a wide variety of file systems or file system types. Some are newer iterations of older ones, while others have specific uses. This article from Medium covers this short list of the most common types. So ext4 is arguably the most commonly used file system in Linux. It's actually the default for most systems today. It is the successor of ext3 and 2, and ext4 provides greater performance and file size limits over the previous two iterations. So it's BTRFS. That's another file system type. It provides advanced features such as RAID, snapshot support, on-the-fly size changes, and defragmentation. So basically, if you have a server with hard disks on it and you just want to change the size of it easily, or implement RAID, or do snapshots of a disk, this file system is better suited for that over ext4. There's XFS, which is typically used for massive storage volumes that hold very large files. You can probably think like data centers. Is what's going to be used. There's F2FS now. That's specifically used with flash-based storage devices such as your solid-state drive. I would assume also like an SD card, you can think of it. That's what that file system is for. So file system partitions and mounting. So a partition is a logical area on a physical storage device such as a hard drive. So basically, it's part of it's a logical division of a physical storage device. Like you can have a 1 terabyte disk, like physical 1 terabyte disk, but you can have partitions on it that divide that total amount of space into various chunks. So partitions allow you to divide the space in physical storage logically um, into different storage locations. In Linux, physical storage devices often start with SD and then use a letter of the alphabet to represent a physical drive. So if it's a storage device, it's SD, storage device. And then if you have multiple disks on a Linux system, you can have STA for the first disk, which will probably have the operating system on it. Then you have SDB, SDC, SDD, and so forth. Now, after this whole characterization here, disk partitions are represented with numbers. So SDA1, SDA2 are two partitions on the first physical hard drive on a Linux device. So to create a partition, you need to first format your disk, if it is not already, to create partitions on it, and then mount the file system on the partition. File systems are mounted by creating directories to mount from them, then running the mount command to perform the mounting. So basically, when you create a new disk, you have to create a mount point for the disk to reside, or the partition to reside on. So RAID, I'm going to talk a little about RAID now. So RAID stands for redundant array of inexpensive, or maybe today more commonly, independent disks. This technology is used to it allows for the space and storage devices to be combined to provide data redundancy. So the main purpose of RAID is to protect data from corruption. For example, if data on one disk is corrupted, then hopefully a copy of it is on one or more disks and therefore can be recovered. Should note that most RAID does this, not all of it, but most of it does. RAID comes in a variety of configurations that each have their strengths and weaknesses. For example, there are some that include performance, while others provide greater redundancy. Now, in this table from data recovery, I've listed the most common RAIDs or RAID types that you see in like classes here and then probably in the real world. I will note that there's actually a lot more versions of RAID than this. There's many, many more. I won't cover the ones that aren't really all that important. So I'll just give an overview of these. So RAID 0. So that's striped data. There's no data protection. All RAID 0 does is it is used for basically for performance. It's to increase read and write performance. That's all it really does. So RAID 1 now. RAID 0 also allows you to have full disk capacity. RAID 2 is mirrored, so basically the data on one disk is completely copied onto another disk. So it's a single drive failure. You can actually lose one and still have your data. It has pretty good read performance, but it does degrade. It does have some. It does come with some write performance degradation. So basically, that's because it has to be accessed. It has to be written twice. So you actually have to write the data once and then copy it again. So write speed goes down the drain quite a bit. Now, RAID striped with parity also allows for single drive failure. Um, it doesn't have great performance, but for it does allow for you to not have to completely copy data from one disk to another. So basically, parity bits are spread throughout the disks. So parts of data, like one disk has an entire bit of data, and then you can split that between all of the other disks. So it's striped with parity. So the parity bit is used so where if one disk dies, then parity bits in the other two can be used to restore that data on the dead disk. Now, Stripe with dual parity basically it's basically the same as RAID 5, but allows for two disks to fail and you can recover data. Typically, RAID 6 is reserved for servers with large capacity requirements, very highly available. It's good for data archiving and backups. One issue with it, though, it does require more disks than RAID 5. You're going to need 4, at least. Then there's RAID 10. It requires at least 4 disks. It increases speed and it's good for back. So basically, it's a combination of RAID 1 and 0. So not only are you getting the performance benefits of 0, but you're also getting the mirrored benefits of 1. So you're getting better performance while also having backups. I think that's enough about RAID for now. If you want to read more on the internet, there's plenty more, like on different versions of RAID and stuff. But for this lab, we're just going to focus on creating a simple RAID 0 array. You're also going to before setting up RAID, you're actually going to take two 500 megabyte disks on your Ubuntu server. You're going to format them. You're going to create partitions on them. You're going to mount those partitions, and then you're going to use them to create RAID 0 array. You will need to look up the tasks in this command. There are multiple solutions. There really isn't one solution for this lab. Please be very, very, very careful when you're formatting the disks. You can really break your Ubuntu system if you're not careful here. Please do not mess with the SDA disk. That's your operating system disk. If you do that, it will destroy your system. So please be very careful and make snapshots. I know I haven't said this a lot in these lectures, but snapshots are crucial to making sure if you made a mistake, you can easily go back to a previously known good state. But thank you very much for watching. I hope you enjoyed this lecture and learned something from it. If you need any help, please reach out to me. Let me know if you need help. Thank you and have a good day.